So looking here, I want to solve for the length of LM and MN for the sketch of the trees. I have all of the measurements on the top, but I don't have the measurements on the bottom. So notice that these two segments, like I was saying, are not congruent. 4.5 and 4.9 aren't the same. But because of the proportionality theorem, if I figure out what I multiply times 4.5 to get 2.6, and what I multiply times 4.5 to get 4.1, I can figure out what the lengths at the bottom should be. So for example, I'm going to start with 4.5 to 2.6. So this is finding how we got this length here. So 4.5 times something equals 2.6. So if I divide 4.5, and again, I'm working with these pesky fractions, 2.6 divided by 4.5, I get approximately 0.58. I am rounding. So because of the proportionality theorem, I know that I can find the length of Ln by multiplying 4.9 by that same ratio of 0.58. So now I'm going to take 4.9 and multiply it times 5, or 0.58. And I end up getting that Ln is equal to 2.8. Now I'm going to do the same thing with CD. So I'm going to figure out what I multiplied 4.5 by to get to 4.1. I get 0.91. So I multiplied 4.5 times 9.1. So I'm going to do the same thing with 4.9 down here to find MN. I get 4.5. So what's happened is I've created 3 proportions. You could also use proportions to solve these. It just takes a little bit longer. But I know that 4.5 over 4.1 is a proportion. 2.6 over 2.8 is the same proportion. And 4.1 over 4.5 is the third proportion. Oh, my face is blocking you. So every single one of those segments can be divided, and they're all proportional to each other because we use the same rate with the number that we start with. So hopefully this gives you a better idea. Sometimes we throw those mathy words like proportions out all the time, but you can kind of see what that means in context of this problem.